Hi, my dears. Uncle Demi. Here I am. How are you? My dears, watershed management is our subject. And we'll divide this subject for simplify it to 5 parts such as Part A, precipitation. Part B, water erosion. Part C, runoff. Moreover, my dear, Part D, floods, and Part E, water harvesting and reference. Look, my dear, watershed management is an important subject, and it is the implementation of management systems that achievement, preservation, conservation, and sustainable use of water and land resources to verify a significant improvement on the inhabitants' living conditions. Look, my dear, Part A, precipitation. It is a term which corresponding or forms of falling moisture from the atmosphere on the earth. Mechanization of cooling air sufficiently is an essential for causing condensation, nucleus, and consequently forming droplets and precipitation. Forms of precipitation. Really, precipitation occurring usually in several forms, and moreover, changing from one to another form during its falling, such as shower, drizzle, and rain. My dears, more of forms of precipitation such as hail, sleet, snow, and hail. Raindrops and affected conditions. Normally, the size distribution of rain covering a considerable varied range with the rainfall intensity, as the higher intensity storm have more large diameter with wider range of raindrops. Falling raindrops will be deforming from spherical shape by unequal pressure due to air resistance on its surface. Hence, drops which have more than 5 mm in diameter will be dividing through its falling in the air. Atmospheric pressure playing also a main role on plowing and movement of wind on Earth's surface, and usually indicating ice power lines of constant pressure on the weather map. Accordingly, the wind plowing reverse clockwise and slightly towards the center of low pressure areas will causing an upward movement near the center. Conversely, the air which plowing clockwise and slightly out of center of high pressure area causing a downward movement in the center of high pressure as shown in the enclosed figure. Precipitation motivators and types. Generally, there are 3 major types of storm precipitation according to the motivators and process, which causing a lifting and cooling the moist warm air and consequently falling rain. Number 1, frontal storms, which occur at boundaries of post-warm moist air and relatively dry cooled air, as shown in the enclosed figure. Figure showing gradual development and disappearance of frontal storm. Look, my dear, the cold front occurs when the cold air is able to push the warm air back, while conversely, the warm front occurs when the warm air pushing the cold air back upward, as shown in the enclosed figure. Figure showing different types of development fronts, such as cold front, warm front, and stationary front. Number 2. Convection air mass storm. Really, it results from solar heating of the air near the ground surface. The heated air moves and rising upward as a result of cooling by the surrounding cool air and expansion process. Accordingly, it forms the convection cloud have more amount of water vapor and unstable at the same time, causing condensation that may develop into thunderstorm and heavy precipitation, as shown in the enclosed figure. Number 3. Orographic storms. This is influenced by topography as air masses move over a high elevation such as mountains. Hence, the air is pushing upward across the mountain ridge and so cooling and reaching the condensation point, as shown in the enclosed figure. Precipitation size and speed. Size, velocity of fall, and the density of particles for various types of precipitation are different from fog to cloud bursts, as shown in the enclosed table. My dear, look to the different types of precipitation such as fog, mist, drizzle, light rain, moderate rain, heavy rain, excessive rain, and cloud bursts, and the specifications of each type as shown in front of you. Koppen climate classification. It is one of the most widely used climate classification systems. It is first published by Vladimir Koppen with some modification by Rudolf Geiger until sometimes known as Koppen-Geiger climate classification system. This classification divides climates into 5 main groups, which each group being divided based on seasonal precipitation and precipitation pattern. Table showing Koppen climate classification symbols by the first 5 groups and both second and third letters. My dear, most summer rainfall occurs during thunderstorms and from occasional tropical cyclones, while humid subtropical climates lie on the east side continents, roughly between latitude 20 and 40 away from the equator. Measurements of precipitation. All forms of precipitation are measuring on the basis of vertical depths, which accumulate on a level surface by rain gauges and measured in millimeters or inches. Generally, there are different types of rain gauges, either recording automatic or none, as follows. 1. Standard weather Bureau rain gauge. It is a sample type of non-automatic recording gauge, as shown in front of you, my dear, in the enclosed figure. Siemens rain gauge. It is a type of non-automatic recording gauge also, as it gives the total rainfall that occurs during a particular time is normally equal to 24 hours, as shown in the enclosed figure. Figure showing Siemens gauge. My dear, look to the dimensions of its path. Bergson weighting rain gauge. Water is caught in a basket placed upon a scale mechanism. The weight of water compressing a spring, which is recording through an appropriate linkage on a chart placed on a clock-driven drum. The recording mechanism allowing the needle to reverse itself 3 times for a full compression of the spring, giving a large vertical scale and more accurate reading of the chart, as shown in the enclosed figure. Weighting basket ringing. It essentially consists of a receiver basket supported by a spring or lever balance. The movement of the basket is referring to increasing the weight, which transmitted to a drawing pen on a clock-driven record drum, as shown in the enclosed figure. Tapping basket ringing. It consists of a receiver has 30 cm diameter placed on a funnel. Pair of tipping basket is fixed under the funnel in such a way adjustment for allowing an exchangeable movement as one basket receiving 0.25 mm of precipitation will flow its contents into a container behind and allowing the second basket to be in the right position under the funnel on a rotary movement. This movement completing an electrical circuit causing a movement of pen which recording on a chart placing on a clock driven drum as shown in the enclosed figure. Float siphon ringing. It consists of a funnel has 127 mm in diameter, fixed one side of a rectangular container. A float is adjusted inside the container and connected by means of float rod, which connecting with the recording pen and actuated drum by a clock mounted on the other side of the container, as shown in the enclosed figure. Microwave radar apparatus. It is an updated apparatus has a short wavelength for obtaining a rough information about the intensity of rainfall in the area. On the other hand, the satellite remote sensing, which is instrument provides an adequate representative on the state and dynamic change occurring in land, coastal, and oceanic ecosystems. The monitoring global record precipitation largely depends on satellite observation, especially in areas where the surface precipitation gates are not visible. Satellite sensors recording various parts of the electromagnetic spectrum that zero and practice show are related to the accuracy and intensity of precipitation. Look, my dear, satellite sensors include two categories, the thermal infrared and the microwave part of the electromagnetic spectrum. Rain gauge network. Network of observation stations of rain gauge should be representative situated to cover all the basin area for obtaining an accurate data of precipitation. The gauge or network density is the ratio of total number of gauges to the total area of catchments. Take into consideration that not less than 10% of the total number of gauges in the network should be self-recording types for achieving an actual evaluation of a star. Several studies have addressed the approaches to improve the rainfall estimation based on the point measurement question, which defined also by World Meteorological Organization, has demonstrated that the network of rain gauges can be designed by using a spatial correlation approach which depends on horizontal homogeneity of rainfall gauges, as illustrated in the enclosed equation in front of you, my dear. Look, my dear, an equation which defines the relative mean error of observed monthly rainfall at a given area. Analysis of precipitation data. It is important really to study the rainfall data of a considerable area as rainfall intensity, duration, and frequency. In addition that, average depth of precipitation and methods of presentation are very important features for analysis data. Look my dear, the rainfall intensity is usually expressed in inches or millimeters per hour, and generally there are an inevitable proportion between intensity of rainfall and its duration. On the other hand, it is observed also that a storm which has more intensity has a larger recurrence interval than less intense storm at any given duration time. Rainfall data. Actual recording of rain gauge data is known as point rainfall, which can be recorded periodically, such as daily, weekly, monthly, seasonally, or annually, in the form of a bar graph. The lines on the chart represent an accumulative rainfall curve, while its slope proportional to the intensity of rainfall. Presentation of data can be shown by either intensity histogram, which showing rainfall intensity against time, or by mass rainfall curve, which showing the total rainfall against time. Figure showing rainfall intensity patterns, such as uniform, advanced, intermediate, and delay, are shown in front of you. Average depth of precipitation. Really, there are three main methods for calculating the average depth of precipitation depending on the area of basins as follows: arithmetic mean, season method, and isotone method. Arithmetic mean. It is the simplest method which can be calculated by dividing the sum of all the rainfall gauge readings by its number as shown in the enclosed equation. Season method. Season polygon method is more accurate, taking consideration the coverage area by each gauge. Hence, it gives the average precipitation value which differs than the mean value. Anyway, the average precipitation over a watershed area by season method can be calculated as shown in the enclosed equation and figure. Look my dear, example and solution of calculation both the arithmetic mean depth and the average precipitation depth referring to season method. Ice tool method. Ice shed is a line on a page of rainfall map showing the equal rainfall readings. Accordingly, any ice tool map showing contours of equal rainfall precipitation, which is known by ice tool lines. Anyway, the average precipitation depth over a watershed can be calculated as shown in the enclosed equation. Figure showing the average depth of precipitation by the isotone method. Look my dear, this is an example and solution of calculation the average precipitation depth referring to isotone method. Follow my dear by yourself, it is so easy. Two-axis method. It is based on three assumptions inherent in the season and ice tool method. This method follows 4 steps as shown in front of you my dear. Follow it by yourself, it is so easy. Calculation Mention the station weight of each rain gauge station as shown in the enclosed equation, and figure showing the standard two-axis method for calculating the average depth of precipitation. Probability of frequency rainfall. The rainfall expected for specific probability is the depth of rainfall that can be expected in a given period, hour, day, week, month, or year for a specific probability. It refers to the minimum amount of rain, which can be dependent on irrigation scheme design and often denoted as dependable rainfall in irrigation science. Look, my dear, the mean deviation, the standard deviation, and coefficient of variation are calculated as shown in the enclosed equation. Look, my dear, the probability of accordance P% can be calculated by following several formulas as shown in the enclosed equation. Follow it, my dear, by yourself. So easy. The recurrence intervals or the term period T is expressed the number of years in which some annual observation is expected to occur. Generally, the probability of frequency occurring rainfall can be calculated by following several steps as shown in front of you, my dear. My dear, look, there is steps of calculation the probability of frequency occurring rainfall. Look, my dear, an example for calculation the probability of frequency rainfall in Central Tanzania Region according to the annual rainfall registered during 1980 up to 2010 years, as shown in the enclosed table. Table showing the frequency vector K for various probability of occurrence. Look, my dear, this is very important. Solution of the example. Look, my dear, and follow the solution step by step. It is so easy. My dear, the rest of solution steps. Figure showing the interrelation histogram between the annual rainfall per millimeter and observation years. Table showing the calculation of mean and standard deviation. Table showing probability of occurring P and recurrence intervals T of the ranked annual rainfall per millimeter. Figure showing the interrelation between ranked rainfall per millimeter and probability at recurrence and expected rainfall. Table showing the expected rainfall at selected probabilities and return periods by the numerical solution. Look, my dear, table showing the expected rainfall and return periods as selected probabilities, both graphical and numerical solutions. Note also, the estimated rainfall depths as the selected probabilities or return periods derived from the graphical solution are slightly different compared with the rainfall depths obtained by the numerical solution, which is more accurate. Goodbye.